Okay, this is section 3.3.2, complex numbers, 3.3.2 for each of the algebra classes. So we talked about the real numbers. Those are the numbers we've been working with for a while. Those are 1, 2, 3, and the rational numbers like 1/2 and 4/5. The decimals somebody said today, and then the irrational numbers like the square root of 2 and pi and all those numbers we talked about. And we also talked and we just learned about and just started using this I thing, which is called imaginary. For those of you who want to go look it up, go find Doug Henning on YouTube, and you will see where that reference comes from for SpongeBob. We got the imaginary numbers, that stuff that has that magical I in it. So when we take the real numbers and we combine them with the imaginary numbers, we get what we call the complex numbers. Complex numbers. And the complex numbers has this real part we're going to call A, and over here we're going to add to it an imaginary part called BI. Both A and B are real. In order to make the imaginary part, we multiplied this real number B times I. So an example of a complex number is 4 plus 3I. Got the real part, the 4 is real, the 3 is real, but since it's multiplied by I, it's multiplied by the imaginary part. This part becomes imaginary. First thing we need to talk about is equality in a complex number. An equality in a complex number, if I have two complex numbers, A plus BI equal to C plus DI, by definition, equality, this implies, that's not a very good implies, this implies that A has to equal C and B has to equal D. That has to be true or they're not equal. So for example, if I had my 4 plus BI equal to negative C plus, what do I want here, 2I, by definition of equality, then 4 has to equal negative C, 4 has to equal negative C, not written very well, and B has to equal 2. This makes negative 4 equal to C. Okay, that has to be true. We're going to use this in our example here. Our example out of the book is that 5x minus 7 plus, this is the real part, the 5x minus 7 is the real part, the imaginary part is y plus, oh that's bad, that is bad, come back here, y plus 4I equal to 13 plus 11I. Now, both of these are complex numbers. This is the real part of this complex number. This is the real part of the imaginary part. We multiply this part, the real part, times I to get the imaginary part. This is a complex number. 13 is the real part, 11I is the imaginary part. What that means by this definition of equality is that this part right here, the 5x minus 7, has to equal the real part over here. It has to equal 13. That's not good. It won't let me do it. What did I do? It has to equal 13. Ooh, 5x minus 7 has to equal 13. And the imaginary, the coefficient of the imaginary parts, the coefficient of I, the number that we multiply I by to make it imaginary, this y plus 4 has to equal the imaginary part over here has to equal 11. So what I'm looking for, the values of x and y that make this equation true. Otherwise it's no good. Over here I get 5x equal to 20, x equal to 4, and 4 equal to 7, y equal to 7, that's a y equal to 7. These values for x and y make this equation true. They make this imaginary, or this complex number equal to this complex number. And I'm not going to do another one of those. The next thing I'm going to do is add two real numbers together. Add two complex numbers together. I'm going to add together, I'm going to add 8 plus 3i. I'm going to add that to 4 minus 10i. Sorry for the writing here. I'm having to go back and forth and look at two different things and write on a third in order to make this work. That's a plus. So when I add these numbers, I add the real parts, the 8 and the 4 are the real parts. I get 8 and 4 is equal to 12. And I add the imaginary parts, the 3i minus the 10i, and I get negative 7i. Now, so that's an example of addition. Now suppose I wanted to subtract one complex number from another. 8 plus 3i, let's not change the number, 8 plus 3i minus 4 minus 10i. Two complex numbers, I'm subtracting the second one from the first. I get 8 minus 4, which is 4. I get 3i minus a minus 10i, so I get 3i plus 10i, I get plus 13i when I subtract this imaginary number from this one. And finally, as the last part of this part of the lesson, I'm going to multiply these two real numbers, or two complex numbers. 8, let's slow up here a minute. I'm going to multiply these two complex numbers, 8 plus 3i times, and if you notice there's no sign between them, so I know that when two things in parentheses are next to each other that I multiply them, minus 10i. And the way I multiply these is I FOIL them. I multiply the first two terms together, I get 32. I multiply the outside terms together, I get negative 80i. I multiply the inside two terms together, I get plus 12i. I multiply the last two terms together, I get minus 30i squared. I squared is negative 1. We already learned that. So I'm going to mark this out, and I'm going to change this sign to a positive 30. Now I'm going to add 30 to 32, and I'm going to get 62. I'm going to add the parts that have the i's together. Negative 80 plus 12i is a negative 68i. So when I multiply these two complex numbers together, I get this complex number down here.